Hi Pre-Calc, I'm back with the 4.5 lecture. We were discussing how we use the unit circle to find the standard table of the cosine. The process is the same for the sine. You would just pick the second values around the circle. And then we drew the standard graph of the cosine and we discussed some basic properties of it. So now I want to talk about how you move the graph around. So I'm going to just write out the generic equation. I'm trying to remember how your book writes it. So okay. So this should look somewhat familiar to how you've moved other graphs around. So see if you can figure out part of it. So this A is what we call the amplitude. And that will stretch your graph vertically. So this will be a vertical compression or stretch. So like if you've ever seen the waves at the ocean, you could say either the waves are high or the waves are calm or low, right? So it's like how high the waves go. Are the waves really high and really low, or is it just sort of a mild oscillation? That would be what we call the amplitude. B is what we call the period. Let me just fix that light real quick if I can. Okay. B is what we call the period, and that is the horizontal compression or stretch. And let me just add a little more detail here. You're stretching this if the absolute value of A is greater than 1. You're compressing this if the absolute value of A is less than 1. You're compressing the period if it's greater than 1, and you're stretching the period if it's less than 1. That one's inversely related. Okay, C is what we would call the shift. Let me be a little more clear. That's your horizontal shift. So just as you know before, if it's positive, it's to the left. If it's negative, it's to the right. Now, the horizontal shift is not going to show up as clear because if you have both a B and a C, the horizontal shift is going to be a blend of the compression or stretch horizontally with the left-right movement. So that should sort of make sense to you. Like if you squeeze a graph and shift it, where it stops and starts and moves to is going to change. It's not going to be like blatantly obvious to what that point is because the whole size of the function has been shrunk down to very tiny. If you move very tiny left to right, it's going to start and stop at a different position as if you make it really wide and move it. So remember, this is not going to be, as the function gets more complicated, you can't just like look at the trig function and see exactly where it's moved to. All right, and as you can probably guess at this point, D is the vertical shift, and that is what will move the graph up or down. That one, as usual, is what we think. Positive is up, negative is down. Okay, gang, so these are going to be the rules, and we're going to start to apply them. Let me just make sure I was clear. So A is the amplitude. If you're compressing a graph, A is going to be less than 1. If you're stretching a graph vertically, A is going to be greater than 1. B is the period. That is the horizontal compression or stretch. If the B value is greater than 1, you're horizontally squishing it. If B is less than 1, you're horizontally stretching it. If you're adding a value on the end and it's positive, you're moving the graph to the right. If C is negative over here, you're shifting, sorry, I don't know what I just said. If it's positive, you're going to the left. If it's negative, you're going to the right. Okay, so these are the general rules for the up, down, left, right, compression and stretch. And as usual, you can, if something is positive, that's going to be its, you know, it's like no reflection. If it's negative, then it's reflecting it over the Y. Same thing with the B. Sorry, reflecting it over the X. Right? If it's just like a parabola, you can make it smile to frown. It's the same thing with the trig functions. You can make them smile to frown. You can flip them over the X. Same thing with B. As all the other graphs, you can reflect them over the Y axis. Okay, gang, I will actually draw them. I know this is really abstract, me just sort of pointing at the rules. Some people just sort of need to see it done. So we will bake a cake, so to speak, after this, so we can sort of, versus just read the ingredients, we can sort of see how it's done. So I'm on it. I'll get on to the next video and you can see how this works in action. Okay, catch you soon. Bye-bye.